very warm welcome from London for the latest in our monthly series of Talking Industry webinars and panel discussions. These are sponsored by Drives and Controls Exhibition, the #1 event for automation, power, transmission and motion control. And the next edition of that will be taking place between the 4th and 6th of June 2024 at the NEC in Birmingham. And it's in association with Manufacturing and Engineering Week 2024, known as Drive the Future. I'll put that in the chat in due course so that everyone can make a note and prepare to come along. So we'd like to thank the sponsors for that. This morning's presentation concerns advances in safety engineering and security. And we have 3 excellent speakers ready to talk to you and to chat amongst themselves and to answer your questions. We encourage everyone to put their questions and comments in the chat throughout the, we don't have a Q&A at the end. We try and make it a discussion throughout. So we want your comments and questions at all times, and we'll take them as we run through the session. So please let us know any thoughts you have, any questions you have, any fundamental disagreements that you might have between what we say and what you think, and we'll do our best to incorporate them all. So we look forward to that. I'm going to introduce the speakers in reverse order. So in third place, but by no means last, you'll hear from Ian Holland, who's Managing Director of DOLD Industries Limited. So Ian, if you wouldn't mind just giving us half a minute on who you are, what your company does, and then we'll move on to our second speaker.
Thanks, Andy. Yeah, I'm Ian Holland. I'm Managing Director of DOLD Industries in Southwood and Ferris in Essex. We exclusively cover the UK for DOLD products, mainly in the safety arena, with some interesting products with wireless safety. I'm going to be focusing today specifically on our STS and physical security. Yeah, thanks for having me along.
Great pleasure, and thank you for that. Ian tells me that he's actually got a good background in IT as well, so we're expecting to see him chipping in when the other speakers give their presentations as well. Our second speaker will be Peter Keckes, Strategic Account Manager for the UK and Ireland at Red Lion Controls. So just a quick over to you, Peter, for a summary.
Good morning, everyone. As Andy mentioned, Peter Keckes, Strategic Account Manager, but my history is coming through the OT and IT engineering and consultancy, and hopefully I can approach with Red Lion strategy of IT data conversions from OT world and transferring of the knowledge from between OT and IT and communications. Some informations for you. Thank you, and
thank you. Peter has worked in both sides of this OT IT fence, so in a sense he's a dual passport holder in modern parlance. So what he has to say will be very interesting, and how you deal with that boundary between 2 very different departments. And opening up for us today, opening the batting, will be David Dearden, who's Managing Director of Euchner. So over to you, David, and then having given your introduction, please go ahead and make your first presentation of the day.
Yes. Thanks very much. Yeah, so I have been on the Talking Industry panel before, so sorry for the people that have got a list of introduction again. But yeah, so I joined Euchner in 2019, right prior to Brexit, to COVID, and obviously our component supply issues that the industry has been facing. So it's been a challenging time. The thing that drives me is the changes in technology, and I'm very fortunate to be working for a company that's very progressive around safety technology, and we're seeing some of those with IO-Link safety coming on board in the not too distant future, and field bus safety. But of course that has its own challenges, and part of that is what we're going to be talking about today, which I'm really looking forward to. Yeah. So, Andy, the thing is, the thing that we're seeing a lot is that the safety solutions are changing in industry from hardwired physical relay-based systems now to programmable systems. Part of that is because the safety IO points cost is coming down significantly, and also the number of vendors that are providing programmable or configurable safety control systems is increasing. So whereas before it was relatively prohibitive to use a programmable safety system on a machine, apart from in sort of specialist circumstances, now it's kind of becoming the norm. And if you've got a programmable controller or a PC-based control system that's doing the rest of the control function, why wouldn't you also include that in the safety functions? It just makes so much more sense. Coupled with that, of course, is that the safety systems are getting more complex. People are wanting to do more and more complex arrangements with their safety, whether it be interventions or with the advancement of automation and technology. So we talk about automation and robotics quite a lot when we're talking on other forums, but one thing that has brought is different challenges. The artificial intelligence. We've been talking about the Internet of Things, but let's talk about connected devices within the factory floor. Ian just mentioned about wireless technology, especially around the safety platform, IO-Link and the like, and remote access. We're seeing so much more greater need for remote access and people to dial into their machines, whether it be the OEM or whether it be the end users, to get that granular data to put the efficiencies in place. And of course, that all creates big safety challenges for us all. The standards are catching up as you'd expect them to do, and is indeed the legislation. So the latest regulation that's within Europe, the old machinery directive, as it becomes a regulation across Europe now, has a very, very strong focus on cybersecurity. And in fact, even when you look at the latest, the fourth edition of 13849 standard, the 2023 standard of 13849, there is a big push on the functional specifications for safety related control systems, and we see that within the text. In the real world, I still think there's some catching up to do, and I hope that we can educate some of the people on the call today if they aren't really sure what needs doing. There is all help available from manufacturers like ourselves anyway, but making sure that you get that specification right at the front end is critical, and the validation and the verification process also extremely important as part of a programmable safety system. And then leading into that, we then bring in the cybersecurity element, and we have got standards. There's standards like IEC 62443, which looks at the cybersecurity in industrial environments, but we are seeing a bigger a presence of cybersecurity requirements, especially when we're opening up ports on the factory floor within our safety-related control systems to the world. So yeah, there's a lot to think about, and hopefully we're going to cover a fair bit of that in the next hour or so.
Brilliant. Well, thank you very much for an introduction, and raises more questions than it answers in many ways, I think. Let's start with the standards bit. You mentioned the machinery directive, and you mentioned two standards, one for safety, one for cybersecurity. Can we put the references to that in the chat so that people have got something to go away with and explore? And this is something that all panelists might like to do as well, is if you have any references to standards or other useful information, then please post it in the chat so that it becomes a compendium of useful information for our attendees to take away with them.
Yeah, no, we can do that, Andy. I mean, there are also some examples, sorry to interrupt there, but there's also some examples that are in the real world where we've seen cyber attacks on manufacturing plants, steelworks in particular. So, but yeah, very, very important that you get that right, because the consequences could be devastating. Of course, they could be. And if you think about the critical infrastructure we've got as well, yeah, it really does need to be considered.
Yeah, we've got a contribution already in the chat explaining the machinery directive and what's going to happen in the future to a little greater extent. Let's have a quick chat with all the speakers. You mentioned programmable safety systems, whereas, you know, what does that provide you with? What would you have beforehand? Just a dumb system that could just do one thing, and now you've got a great deal more flexibility in terms of how you can set things up, how you can change things. What do you mean specifically for the layman as to what is a programmable safety system and what does it give you?
Okay, so as the technology of our machines gets more and more complex, so does the safety requirements. If we go back a number of years, excuse me, and you opened up a control panel on the factory floor, it may have had a shoebox PLC, but it would probably be a suite of relays and contactors, and it would be quite literally relay logic, and it would be very difficult to fault find on. It would be very difficult to do any modifications on, and it was relatively unreliable because there was a lot of electromechanical moving parts. And although the general machinery control advanced into the programmable controllers and the PC-based controllers that we see of today, with decentralized and remote I/O points, making that side very, very easy to configure, the safety was always left behind a little bit. Now part of that is because it used to be acceptable that we would want to shut down a machine and we would just shut down the machine. Now it's a little bit different, and people want to do different things. They have to do different things because the risk assessments or the way that the machines operate based on inertias or the way the operators interact with the machine requires them to do different things. And so the safety solutions have got a lot more complex. And to do complex controls using safety relays is quite a challenge. And again, you have the same problems that we had 20 years ago in the normal factory floor, 20 or 30 years ago in the normal factory floor, that they become, when you get complex, they become difficult to maintain, unreliable. And actually then when you've got the skills gap that we're seeing as well, you find that sometimes these complex safety electromechanical systems are circumnavigated when there's a fault at 6 o'clock at night and you need to get your factory running, and then that never ever gets resolved. Now, so the same way that we've seen standard control move into programmable, we're seeing the same with safety. And the leading manufacturers have all now got a good safety offer within their PLC range, which makes it very, very easy to have the standard control and the safety control on the same platform, and all the benefits that come with that. So we can obviously send data between the standard part and the safety parts, and vice versa for diagnostic purposes. So we're now getting a lot more information. We can make the changes that we need to do when we need to do them. But of course, that all comes with the caveat we've got to have greater understanding and knowledge about what we're doing, because it's very easy to put some code into a PLC that may not quite do the function that you want it to do. So when you talk about the latest version of 13849, and we're starting to look at the requirements for putting, you know, better specification at the front end, and it is really, really important, that is to try and mitigate some of the issues that we have further upstream. You know, years ago, there was a report that was produced by the Health and Safety Executive called Out of Control, and it looked at where these errors came about, and the majority of the issues came in the design and realization phases at the front end of the project, not in the realization and the operational pieces at the second end. It was down to the design. Something had gone wrong in design, and so it's really important with programmable systems we get that bit right. But you know, we are seeing all the benefits of field bus, factory field bus technology, we're seeing a massive growth in that. And I say hopefully when IO-Link safety comes on board, that's also going to get it right down to that sensor and actuator level down absolutely on the shop floor.
But if it's programmable, doesn't that give you more flexibility to make adjustments later rather than perhaps everyone agrees it's good
there are benefits of it and also negatives for it. As Andy mentioned, there's lots of things getting more clever, and you do have a designated PLCs, which are safety PLCs, and you are able to communicate between safety PLCs and the control systems, for example, for the machines. But there is still, and versus of the flexibility, what you're gaining with that, there will be still a very strong push from some industries to have it hardwired. And of course, why is that? A hardwired system is still gonna have a benefit of speed because it's analog and doesn't do any conversions between analog and digital world. And it's operating not with the programs and some CPUs, but it's working on the simple logics. Then there is a place, on depends on the industry, where you can go digital full, and where you can only, I would say, even after wiring safety in a hardwire, you still will use the digital because the informations from the hardwire system is still required, and that could be for the multiple different reasons. How you're gonna analyze what kind of safety failure you have. Imagine you could have a production line of the robots sitting in a line or going over 20-30 meters, and then you suddenly have alarms for the safety reasons when somebody opened the gate on different part of it, or there is some problem with where something's interfere with the robotic hands, and this is again safety event which needs to be in some way summarized and understanding how the production lines is tweaked and tweezed to create you the best output. Then even the hardwired system, because the gate will be hardwired, there will be some different digital input into PLC, safety PLC systems. How that exchange of data with the control system is, this is the important things. If in the past, it used to be hardwired, you had digital input, digital output, and the robot stopped. These days, it's not always a possibility to the robot and the production line stop, because it will have a massive impact, and depends on the event. Of course, you do have a digital version of the stop button when something is life-threatening, and you can decide based on that stop whole line. But because you do have the flexibility, what David was talking about, depends of the safety event, you can adjust the machine to work in a more safely manners. You can slow down the process, you can stop part of the process of production, and of course that's gonna have an effect on output. It's making sure when things are safe, but also making sure when you're not shutting down. And imagine you do have a furnace which is 50 meters long, full of the material which is going to be is heat treated on 900 degrees. If you suddenly stop whole production line, the temperature is there and the material stop moving in it. What's gonna happen? It's gonna melt and disable your production line for 1 month, even longer, to clean it up, everything. That means you're cutting your output. You're making literally situations when you have to shut down your productions, and that's unbelievable cost. Of course, you need to understand where you need to do it and when you must do it, the shutdown, and when the shutdown is not really necessary, but by the changing the process, for example, slowing down or adding some cooling systems to slow down and cool the system before completely shut down. This is the adventures of the flexibility of program. But again, it's not what we call fast reaction because the hardware, the analog system is always will be the fastest.
So there's a reason of speed not to move towards programmable, and presumably a familiarity issue as well, where people are safer with what they've got.
You need different skill sets. You need completely different skill sets to do that. Yeah. And I think David absolutely have that in the head. Soon you're going into PLCs, and you also mentioned the possibility to transfer data in OT layer, from OT to IT layer. That's completely different skill sets. While electrical engineer will be able to wire the physical safety and will be able to set it up and get it work. Suddenly you need somebody who is a programmer, which may not have a clue about the wiring system, and maybe not even is able to communicate and understand to person which actually do the physical wires. Then yeah, the system becoming extremely complex. And with that extreme complexity, you need different skill sets across from different regions, from physical through the quality automation to IT layer. And of course, these things we require for multiple reasons, but of course, the system have a different outcome, but also different cost. Adding all these segments, sometimes I've seen it many times, people overblowing it and making it much more robust. And many times, and I'm not saying about the safety, which is life-threatening, but in the digitalization world, I have seen so many projects being overblown by doing it for the sake of technology, not for actually needs of the people, which having direct impact in a production or in industry. And to find the balance, it's not that easy. Of course, you do have all these possibilities, but is that always the best way to scale to build everything to the max? From my point, it's not, because it's never gonna return you what you invest in it. Your time, your money, and the cost of it will go so much high when you maybe can close your business, because there will be nobody capable to buy the machine which is so overblown by specs. It could be the ideal, perfect machines for everything, but nobody will be able to buy it.
I think industry is recognizing that, though, because if you take a modern OEM manufactured production machine that has technology embedded in it, not only can that come up and give great diagnostics to help and assist the maintenance operations within that plant, even relatively unskilled maintenance operations within that plant, to be able to fault find themselves, but actually it can send that information to the manufacturer of the OEM of the machine to say, hey, we've got a bearing failing. It's going to fail in 3 weeks' time on this particular piece of equipment. You probably need to get a service engineer into that plant to get it repaired. And so from the manufacturer, the end user of that equipment that's making chocolate bars, crisps, or whatever else they're making, it kind of takes some of that issue and this skills gap away. And I think that if organizations don't embrace it, they've got to challenge themselves anyway. One thing that does raise, though, is who owns that information. And I know, Andy, you and I have spoken about this before, but that information is key. And if end users don't seem to be getting to grips with machinery purchasing specifications that talk about who owns that data. So these machines are creating lots and lots of data that would give a good indication of where the weaknesses are on their particular pieces of equipment. And I'll give a very, very basic example, and I've used this before, is that if you were a chocolate manufacturer one and you had a new production line put in by an OEM that built you all that line, and the OEM was pulling all the data out, and they can see which bits are becoming unreliable and causing downtime or slowdown within the factory, they could then go to chocolate manufacturer 2 and say, I could put you a new line in, and I know that it's going to be 18% more efficient than your competitors. And that's how valuable that data is. But someone does need to take ownership of that right now.
I think David, you're right there, but there's definitely an ethical question mark above for doing that. Not
Without
saying
a doubt,
it doesn't happen, but I've been quietly listening in the background. There's a few things I've probably got to interject at this point. You said right at the very beginning, David, about the fact that everyone's going electronic and safety based as opposed to relays. Just if you can see above my head, we make thousands, millions of relays in that building every day. Yeah. So the reason we do that is it comes down to knowledge of people who are in the specifying market, as you said, with regard to machinery. It also comes down to cost. Cost is a very big thing, you know, with the price of energy going up, the price of resource and infrastructure spending has to go down, because fixed assets need to be fixed assets. You know, the fixed overhead costs can't flex just because energy's doubled in price. Also,
it was trends, Ian. It was trends more than anything,
Yeah,
and the trend is definitely there. And if you know, if we look at the modern factory plants, if you were building a new car production line or a new warehousing, a logistics center, I'd be very surprised if you based your safety-related control system on relay technology. I'm not saying you can't, but I'd be very surprised as an engineering team if you based it on that, if it was a large-scale plant. And it is just a trend.
No, I absolutely agree. And some of that is down to what the function and fit of the product is. So, you know, I mean, in the 1940s, relays were it. That was all you had, you know. So technology definitely has moved along. I mean, everything you're saying, I agree with all of you, because advocates, we do wireless, we do very successful monitoring equipment, you know, monitoring relays that monitor everything you can possibly think of. But what I find a lot is people's knowledge and understanding via their risk assessment of what level of safety that they want in a particular area sometimes is very lacking. And only after something happens is they go, oh, perhaps that wasn't a good idea. And then you find that safety becomes very much knee-jerk as opposed to specification. I was sitting there thinking, I can remember a little story about that, and you're both coming out almost like you're reading my mind. So I worked for Schneider for a while. I was in the car park during a fire drill. There was a power cut, and Cadbury's Dairy Milk, who were just in the middle of a massive, huge, great production run of Cadbury's eggs for Easter. All of the chocolate went off in the mixers because the power stopped. And they were out of action for 4 months while they unloaded the hoppers and chiseled the chocolate out. So, you know, the necessity. Who was it that said chocolate factory? It was you, David, wasn't it? Yeah.
It was, yeah.
You know, I've physically seen that kind of issue that can happen. Again, that's relevant for the production line. Peter was mentioning about stuff going off in the process of production lines if you haven't got the right contingency in effect. So Peter mentioned something there a little bit about safety production lines generally and the level of safety required inside. So I'm going to put my physical safety hat on for a little bit and talk about design, because when we've got a production line, I agree that a 900-degree piece of steel going through a furnace can't stop because of unless someone's in on top of it, it's going to be fried as they go through the furnace. If you stop it, you're going to be in trouble. So physical security for me, stopping people from physically going where they shouldn't, unless you have to pull the lever that says don't pull this, press the red button that says don't press this red button, because someone's going to die. The less amount of people that you have in that strategic area which is going to cause you a problem, the better it's going to be. There's one other thing that I want to pick up as well, is the amount of communications that we have for safety. So you think we've got CAN bus, Profibus, Profinet, Ethernet, HP, EtherCAT. All of these things exist in different parts of the same machine sometimes, in different parts of the factory sometimes. And just an open question to all of you, do you think that that's the right kind of technology, or do you think, like electricity and water generally, we should have a standard for safety communications? And that gives us the ability to focus then exactly on what we're doing from a safety industry perspective and focus all of our stuff on the same technologies.
Absolutely, I agree with you. It's some things which already exist in IT world, because the safety in IT world is quite standard. And I agree with you, there is absolutely mess in all the protocols and many more. Considering the company where I'm working at this moment is the converter, the protocol converter heart. They talking about 300 protocols, which, if you consider what everything can be, simple generator, look at the simple generator has a controller. The controller communicating by Profibus or Modbus. It does have a safety IOs, which are communicating maybe on a can open. And it does have an engine communication units with communicating on a CAN bus. And put these all together to got all the necessary informations to run the machine or even start the machine, because if the generator is gas generator, it has to have a physical stability ability to recognize when it's nobody around the generator. When the gas opening, it has to be safe environment. As you said, nobody can enter it. You have to make sure that you can do it by physical, you can do it by the camera. These days, you do have a camera vision, which can recognize there is a person. If it's frozen or moving, doesn't really matter. There is a person, you cannot start. And you can start the start button many times. The system has to be designed correctly from beginning. That's where it's, unfortunately, we can't undo 50 years of development. And don't forget, we're not developing by one team. We don't developing in one country. The globe is so great big, when the all different variation will always come. And this is the point where you think how to put all this together. And there are technologies to answer that. There are technologies which will help you. But of course, any technology, and this is another things to have in mind of design, any technology which you're adding into the daisy chain of the data flow from the physical sensor to the actual decision-making unit or CPU, or the decision-maker person which is supposed to decide, it's another weak point in a chain. As many more chains you're putting in together, more possible failures you have. And this is another, how you're gonna create more safe system? By adding more things in the system? Is a question. I don't think so. In my opinion, the system should be, as you said, unified and as simple as possible, because then you can ensure the stability and safety of the system. As soon you making it more complex, of course, it does have a benefits, but also massive negatives. And as we always starting at these days talking about convergence of data in IT, what we design on OT layer, it may not have any meanings for these people out there in IT world. And the things Ian, you mentioned, or no, David was mentioning about remote access. This is another, I call it hornet in a nest of bees, which you literally opening up. And this is the way how you think. How are you going to open that? How are you going to control that? Talking about multiple things, multiple protocols, and creating hub. That's one way how to do it. The hub could be different. It could be set up as a server, it could be set up as a unique data converter unit. But who's supposed to get access to these data? Which controller supposed to, all the machine builders in the past, and even me, myself, I said, oh, I need this Ethernet switch. And I put it there because it's got 5 ports. That's what I was interested. And that's what they do now. It's cheap. You can put it there, and the HMI communicating with the controller, communicating with the safety PLC, and you got data there. And then I, as an engineer, will come there, plug there my computer, and hey, hello, have a look. I see all. What if somebody else will come and plug his computer in it? And don't need to be even computer. These days, you can go with a tablet and connect to it because it's got Wi-Fi hotspot. And this is the problem. The changing of design is actually on the ground level, on the bottom. If you want to have a safety machine, you have to start with the physical, but also if you're starting into wired systems, you're not gonna put there simple switch, which opening it anybody to connect to it and change the things. One example is I was designing hydro power stations, and the customer was Adam, and I want to have access to this by HMI. And then to HMI, he could remotely dial up. I said, that's not a good idea. It's a safety feature, it's a protection, and there was a protection settings. And it's, no, I'm gonna disable it when I want. I say, you cannot disable it if you are not there. Why not? Why not? I said, just don't do it. And he did it. He did it anyway. What happened? He remotely disabled over speed protections on the hydropower plant, which meant because he wasn't there, he couldn't hear what's happening there when the turbine running on high speed. He press start button remotely and blow up whole panel, because suddenly when it's system excited, except of having 380 volts, he had a 1200 volts. The only things what survived was actually controller, which was designed for the marine environment and was able to survive 1200 volt. And that's the only way how we recorded actually what's happened. And he said, no, Adaman, I can remotely control everything. No, wrong. Only person which is responsible and does have a knowledge can probably access it features, can access it. Even can access the HMI, which is designed to do operations. The other one maybe can decide, have access to the PLC logic, and another one to PLCs, safety PLCs. This is somewhere needs to be decided. For this is necessary to have the remote access management system, where it can say this person with these capabilities, they can access different layers of your system. And this is something which in many cases is missing out there, or is not really dig deeper. But it's something what in IT perspective is already working. It's working when, yes, if you do have a corporate laptop, you can work on everything what is installed from your corporate website. But if you want to install something else, you need special access, special password, IT administrator password. The same things we need to have on our OT layer, because then the safety of the system will be fulfilled. Otherwise, if everyone can do everything by just plugging on the unmanaged switch, oh, there is a problem. That's not the right way.
I mean, that's
So
amazing,
can I
really,
just-
that you wouldn't have that as standard, because, yeah, as you say, in IT systems, that's, you know, and even outside manufacturing, you know, we're all used to different levels of privilege for different types of user. You know, I mean, I run a junior cricket coaching business, and, you know, I can access the junior records of my kids, but I can't access the records of the club down the road for obvious reasons. And, you know, it's just simple access provision, isn't it? And
yeah, but it's
why don't we have
it's a
it?
historical thing. It's a historical thing, you know, in OT layer, because it was all disconnected. You didn't really need that. But now when it's coming and getting connected, a very good example is it's for life science data recorders. The data recorder, designed in 1980s probably, had a couple of layers of access. The reason was because regulations was telling them, if you want to approve this change, you need to go and ask somebody who's got the approval rights. But that was already transferring a little bit data in 1980s from OT layer to IT layer, and required base of regulations. And yes, people fighting with the regulations because it's adding complexity and adding some bottlenecks. But in some way, they're helping to unified systems. And this is the important part of it. If you're not going to unify systems, you're going to overcomplicate it. And from machine to machine, it's going to be all different. And as it is now, and find the right way around it, it's going to take probably a generation. It's not things which we can change. You know, when I started in IoT industry was 10 years ago, and everyone's thinking how big boom it is. Is it? It is a big part, but actually the IoT world in OT world, it's something which was there in 1960s, 70s, when the first SCADA systems on utilities were existing and were doing exactly the same, which of course, much less data, but they were actually secure because they were physical separated networks and still are. Then again, down to the design, we're going to end it up, and if things are designed well in the beginning, they will work much smoother. But who is arranging the design? That's the questions. If we're gonna access it one way here in UK, then there could be somebody else accessing it in EU. They created their own directive. If you're gonna go to US, it's completely different story. And if you're gonna go to China or Japan, you will be surprised what is possible and not possible there. Then, it's a not simple decision making when everything's applied everywhere.
But that business
Peter, I was
intelligence
just
is
thinking,
critical.
Peter, the analogy you gave with the cards, RS232, RS485. Sometimes even trying to connect when you have the password is difficult.
Yes,
if you
yeah,
didn't get the modems right, But do you think then that the IoT of things is going to change to much more like the current Microsoft-esque and Google multi-layered authentication with mobile phones, that kind of level?
Again, depends where you are. I think US is set up for that, and I like something what our CEO said, and in American company said, Americans need things simple, and if there is a technology which simplifying things for them understanding, like for example cloud, yes, that's answer for them. If you're gonna talk to Europeans, it's different story. If you're saying Germany or Italy or any other countries in Europe, they are much more into engineering, have their own control over the things. And that's why, for example, Amazon or Google or Microsoft can see much lower revenue from European countries to go into their clouds. One thing is possibly trust, but other things is a control. And sorry, I tried to get the data and into IoT platform multiple ways. I started with things like doing it by your own coded software, your own gateway. Then I used to standardize things and use OPC servers and with some additions. And then I have tried also AWS or Azure Edge, where I can tell you, when I move away from OT to IT technology more and more, the things went so much complicated, so much promoting. They saying they are more scalable, but from my point of view, they just creating that chain of the problem technologies, which creating more and more weak points in the chain. Then they on the end did not simplify. Of course, for end user, it's like I always having fight with my wife. I am Android user and she is Apple user, iPhone. And she's saying because she like it, the simplicity. Yes, but I don't have a power over what I can do with it. That is very restricted what I can do it. With Android, I do have more. And it's, again, probably the comparison of the mind. And now generalizing, of course, not everyone's in US is like that. There is lots of engineering coming, and engineering of my own portfolio is coming from US. But in a generalizing, when you're talking about general public, they want things more simple. They want things used.
But Peter, though, I think you've hit
Sorry,
when you mentioned about the iPhone and the Android, that picks up what Ian was talking about earlier on about the standardization of software. Now, I'm not for that. I'm actually against that. I think it stifles innovation, and I think that we need different technology platforms. But everything we've talked about today is around application, because actually there is some great standards, there is some great legislation in place, but people aren't following it. You take cybersecurity standards 62443, the programming standards for PLCs 61131 part 3. There is guidance and knowledge and support out there for people to apply the technology in the right way. In my mind, the issue is that for whatever reason, and I don't know the answers, people aren't applying the technology in the right way. And I think we need to get back to that. Martin Kidman put a little note in the thing about it starts with a risk assessment, and it absolutely does. And within that risk assessment, that isn't just about, oh, can my hand get trapped between this pneumatic cylinder and this end stop? It's around things like remote access, cybersecurity. All of those considerations need to be made in that risk assessment, because they are the risks that we're identifying as part of that whole assembly. And that's the bit that I struggle with. So, Ian, I think it is a really, really valid point. And I think there's a big issue around software and lack of knowledge. And I think that's where the problem is, and probably the investment needs to be made in the skills shortage. And let's be right, if you go
education.
into every technical college in this country, there's very, very few of them that are teaching machinery safety or industrial safety systems and cybersecurity as part of their engineering courses. I know that because we're working with a few of them to try and get information on their curriculum, but it's not an easy task.
Right. Well, that,
To
I
what
think, do you not think
extent
though,
are,
that
sorry, Ian,
historically,
go ahead.
that's because someone, so you know, if you think about the 70s and 80s, you'd have a guy in a blue coat, and he'd take delivery of his fantastic Swedish machine that would be delivered, and he'd have a cupboard, punch cards. You know, there was no requirement to download drawings to it to do its thing. There was no requirement. He was the guy that was in charge of it, and because that's kind of where the machinery exists from, the IT part of it is like for those guys specifically, you know, they're engineers and they're physical engineers. They're not security engineers. They're not software engineers. They like Windows 95. You know, they're kind of boxed into what they're thinking. And although you've got maybe their bosses, and I don't want to be stereotypical, but you've got people that are a bit further up the chain trying to integrate all of that kind of stuff into a corporate area. And you know, you should imagine the IT guy sitting in the comms room with two cables and going, well, that can't talk to that one, and I want to keep that separate from that one, and nobody needs to get into that one, and where do I put it? Because they're not used to that kind of level. Sorry, Andy.
It's part of the problem with standards that standards are not keeping up with the technology, or is that not an issue? You know, you mentioned the fact that people aren't following the standards. Is that because they don't know the standards are there, or is it because the standards aren't really applicable to what they want to do? Anybody have a view on that?
I think it's not even standards; it's even some aspects of legislation. Andy, you know, take something very, very simple, such as the provision and use of work equipment regulations in the UK. There are still some big organisations that aren't complying with that. But you go into the public domain prosecutions database on the government website and see how many organisations have been prosecuted under Regulation 11, which is the safeguarding of machinery regulation within Pure. And it's scary, and the fines are significant. Yet you probably could go into many in one day in any particular area and say, have you done your Pure assessments and have you got documented evidence of that? And probably many of them haven't.
I think as well, when you look at those prosecutions, I've had a look at some of those. It's 90% of them are where people have ignored their risk assessments, and they've ignored the Pure legislation, and they've put a magnet where they shouldn't have put a magnet, and they've circumvented a guard.
And Ian, you're absolutely right. And actually, where we were talking earlier on, and I know Peter mentioned about over complexity and isn't a fan. I used to open up electrical control panels, obviously supervised in the past, and saw wire links across a safety relay between 13, 14, 23, 24, 30, and the electricians had shorted it out because on the night shift they'd had a problem. Easiest way to get the machine up and running. I have never ever seen that within a safety functional controller, because it wouldn't work, because the safety functional controller has enough diagnostic coverage systems and enough technology in it to say, that wire link, mate, you can't work it. I'm shutting the system down. Yeah. So actually, it's making the system safer, but it just is a different technology skill set that's needed to maintain them, in my mind.
Yeah, and this is a problem, the skill set. I've been in factories where they wanted to digitalize, and you're coming into this massive factory full of machines, hundreds and hundreds of machines there. And I'm saying, okay, I'm supposed to connect to this machine. What does it have? A controller? I said, well, there is a HMI. I said, that's HMI. That's not a controller. I cannot connect to HMI. It's maybe give me some information, but we cannot open a panel. I said, what do you mean you cannot open the panel? When you are a maintenance engineer here. Oh, yeah, I am a maintenance coordinator. I have to call third-party company to open a panel for you. And that time to saying, hold on a second, and if you cannot open a panel of your own machine, I don't know what's the reason, but how you can actually know what the machines do, how it operates, and what are the safety in it, you cannot even open it. Of course, it can come to the another situations, and I'm gonna mention some things which they required from me on one project to connect to SCADA system. And the SCADA system have so many hurdles, licensing hurdles and physical network hurdles to connect to it. When the client said for him, it's impossible to fulfill them. And I came on the side and said, can we open panel? Yes, we can open panel. I opened the panel, and I'm gonna say it again. There was a machine which probably was complex as a small nuclear reactor, costing millions. And there was a couple of PLCs and the switch. I said, can I plug on that switch? Oh yeah, of course. I plug in the switch, and within 5 minutes, I had around 10,000 tags from that machine. I know exactly what the machine's doing. And this, if you consider, this was a training center, but this, if something like this gonna happen, and it's not about being able to look and change things. This is just to acquire the knowledge, what actually machine's doing, how it operates. It's all already giving you massive breakage in security and safety. Imagine when you do gain this kind of access to the system, and you don't need to have a virus to plug that. You need to just change a little bit of logic. You need to just change some things which will delay some reactions, which will silence some alarm. That means you affected the system, which on the long term doesn't even show anywhere. Nobody will know, except of probably in 12 months, whole system collapse, melt, crash down. And I think this is the approach, how it exists. I know we're talking about it a lot, but it needs to come down into, as you mentioned, to education, to people coming into work with that. When I know the safety is first, and then on top of that, I can build the system, which will work. At this moment, the design is opposite. I need this functional system. And then when it's done, I'm gonna look what safety I need to apply on it. And if the design would be changed, and when we're gonna say first the safety, how to design everything. And I'm not talking only about physical safety, but accessing safety, security, and ability to integrate it, because we're not gonna stop progress, and we're not gonna have for a very long time machine disconnected in the factories. Because why would we? It's giving us knowledge, it's giving us important, it's giving knowledge to the manufacturer of the machine. And there is always chicken egg, who's on the data? Question is, all of them, in some way, all of them, because one is producing and owning the machine, the other one because it's designed the machine. Again, separation, which data are important for who, and how should be DNA, should be a document, agreement written between them, how they gonna from legal point behave. And you said previously, go into third party company and offer machines which is 18% more performance better. Yeah, if you're gonna be able to legally say, yeah, that's not possible because I do have agreement with this company and I need to first offer the improvements for the company where I aggregate the data. Again, it's a contractual, and that's another haywire. That's another mess of law going around it. And if you're going into software world, the law and the mess around the law and all that copyrights, rights around it, it's even more complex than OT layer. And that's probably for much longer talk, and probably even some different type of people, because even I worked in IT and with the software for many years. Many times I was scratching my head. I just don't understand how small clausula in terms and conditions could clean up a mess which was created by software company on the beginning, or opposite way. you can't blame somebody if you disconnect the safety and then say, oh, I disconnected safety and all blow up. It's your fault. Sorry, no, you should not. You should not. That you were told that not to do it. And again, the correct documentation is coming from a machine builder. If machine builder say, this is how the machine should be used, this is how you can connect it and integrate it with your system. This is again lacking in many manufacturers, OEM builders, because they don't really, and I wouldn't say care, but when you're saying a machine, this is your process. You get order, you're building, selling it, you ship it, and maybe you got some maintenance contract. But do you want to get involved with IT in that corporation where you ship it and where you sell it? You don't have maybe people for that. And many times people coming to me with the questions, we want to integrate it, but we don't have IT people. For me, cost of the consultant in IT to integrate it with IT of some customer will be actually triple cost of my own installation. And the customer wouldn't want to pay for it, or it will be very complex and a more expensive exercise. How to break through this? Of course, there are technologies to do it, but again, it's agreement between manufacturer or producer of the machine and consumer or the customer. There has to be always sometimes deep legal, sometimes terms and conditions are enough, agreements between them, and then the both can benefit from it. The manufacturer or the producer of the machines can get the data and produce better machines in the future, or can do the predictive maintenance because technology allows that these days. But again, how deeply he should go? Should he really get access to everything? Should he have access to code in the machine while the machine is running in production? Of course, there should be some restrictions. And again, the system should be designed a way where saying, yeah, machine is in a shop floor, unless you have a green from the user, from the customer, you're not accessing it. You can access the data, which could be treated somewhere in a cloud or in private data center, doesn't really matter where, but you're not playing with a machine, which is like you're not playing with in a transformer with a life. You have the distance. As Ian said, you have the physical distance to mess with it. If you want to break the distance, you don't even need to touch it. It can kill you still. And the same things. You may not touch the code itself, but you can make in a software small adjustments of something that you don't even think it can have an effect. But there is so many dependencies on each other when the whole product can collapse. And that's the power of the software. It can be very flexible, but one small mistake, which is not properly tested before it's put in a production, it can cause collapse of the machine. And maybe kill somebody, of course, but it's a much more complex things to communicate the physical safety and move it into software world and in IT world. It's a long-term way. I would say generations on.
A robust validation and verification plan. We always would suggest that you have someone different than the programmer that actually wrote the software to do the checking of the software. So you've got two trains of thought. But that then goes back to what I was saying before around the 4th edition of 13849. Let's really get that functional requirement specification, the safety requirement specification nailed down at the front end, because unless we've got that nailed down at the front end, we've got nothing to validate against. And that's, again, going back to, I think the technical documentation is there, the assistance and support is there. It's just the application that we need to get right. And I do see people making software changes on PLCs, safety-related PLCs, without due consideration, I would say. And it worries me. But please rest assured that any Tom, Dick and Harry can't get into that PLC to change the software code. They're all locked down. They all password protected, and they all have some form of cyclic redundancy checks, so a CRC element to them. So even through documentation and traceability, you can even put code within your standard part of your software in a lot of controllers that says if the CRC isn't this, then you're not going to run. So the machine won't run if someone makes some changes that's not authorized, without obviously then changing other parts of the code, which then gets more complicated. But it is a challenge. But once again, I think we go back to the different skill set there, you know.
So David,
We always
do you
sorry,
think,
Ian, go
David,
last time, and then we must move on.
David, do you think then we should have some kind of dedicated risk assessment and safety level accreditation for the software and its accessibility for or its ability to cause an issue through clandestine methods?
Yeah. So that's really challenging, because, you know, we go from safety relays to configurable controllers to fully blown programmable controllers, and then go into the control systems from the process environment as well, which then takes it to another level with another set of standards behind it as well. My own take on it is that give the people the knowledge to do the right thing. There has to be some education within industry, that the people in the position of control and authority have to understand that they need to invest in their people to give them the training and support and knowledge to be able to support these systems, you know, the new systems. They wouldn't put a robot on the shop floor and expect someone that has never worked on a robot before to put that into production. And nor should they do with the programmable controllers. But actually, Ian, I think sometimes engineers are also a little bit underspoken in industry. You know, they should be going to the senior management and saying, I need this, I need that, and I need the other, and I can't do my job without it, and really putting together a good case for doing it. But I say standardization is a little bit, for me, it's in terms of us all working off the same exact common platform. I say I don't want to stifle innovation. I think that's really, really important, that we still have the flexibility for people to do what they need to do. But there's a massive skills gap, and you'll see it as well. I mean, even on a configurable controller, you know, you could make a cock up and make something work in the complete opposite way that you thought it was going to work.
Yeah.
You know?
And it will pass the logic because
the problem is, if you do have a regulations like IEC 62443, you can say, yeah, the controller or the software platform, they all fulfilling, but I've been assessing platform against this, and you know what is the most common answer for it? Yes, by design. You have to design it within the system. It is capable of doing it all, but is not tick box exercise. It's not something which is automatically set. Then if somebody's saying I need the regulation 2-3-3, I can't say, yeah, there you go controller, there you go software. It's fulfilling it. It's not, because nobody's gonna design it that way, because that means he has to very narrow specify and create a complex rules within the system. And that means the system become inflexible to be applicable somewhere else. And if that's become inflexible to be applied somewhere else, you spend a lot of money and investments to develop the system, which is actually sellable to very narrow space. And that's why all of them, they are capable of doing it, but it's then on engineers when they're designing the process, they're then designing the applications, they're designing the logics within the system, when they actually applies these rules. Then on the end, we're gonna end it up with the people behind that. And there was question why they don't doing it many times. One thing is lack of knowledge. The other thing is lack of resources. If you consider how much the engineering world actually shrinking, because there is not so many young people which wants to go to do complicated engineering. And to be honest, I've seen with my own kids, they are users of technology and they are fantastic. Whatever put into their hands, they can use it within a couple of minutes. But to design new things, that's completely different story. And to go down to the engineering. Like somebody was asking, actually, is there actually a company which creating a program in assembler? And what is assembler? I was shocked. Like, you don't know what is an assembler and you programming computer? Then go there. It's actually the first and the closest language how to communicate with your hardware, with your CPU. And if you don't know what is assembler and you're using Visual C or you're using some different high advanced programming language, you actually not interested on all that rules which applies on the machine level, on the CPU level, on the processor level. You just utilizing somebody's knowledge, which was built by teams, by thousands and thousands of people to create one software, which of course that making your life easier. And from user point, it's put the code in there. It's not that difficult as it was 20 years ago, but it does not let you to fully understand what's happening underneath it. And I think the understanding is getting worse and worse these days because there is a lack of engineers on the bottom layer, on a design of bottom layers. And if it's that safety, security, or any systems out there, IT or OT, there is less and less engineers to be born.
Yes, very, very true, Peter. I totally identify with what you said there. We always promote these sessions as similar to a jazz composition where what happens between the fixed points is relatively unknown. And we have, in fact, managed to go an hour and 10 minutes on pretty much the first presentation, although everyone's chipped in and probably said a great deal of what they wanted to say anyway. And so it's more of an avant-garde jazz session today. But I think it's only fair that we do give Peter and Ian a few minutes just to talk about the subjects they wanted to, even though they already have. And then after that, we'll just try and pull it together with some, maybe just a couple of general questions. You know, we've held our audience very well. They found it extremely interesting. There's a lot of questions in there that we will come back to afterwards and get written answers for, because the webinar is only the beginning of our interactions. It's everything we do afterwards that is particularly valuable. And of course, there'll be many people who will watch this in the future or listen to the podcast who aren't here right now. So bearing all that in mind, Peter, let's just have a couple of minutes on this cultural difference between the OT community and the IT community.
As I probably mentioned it a few times actually through the communication, but I started more than 20 years ago working for IT company. And of course, when you're designing their things there, it's very similar. You do have different layers of the network, and you do have a major network that manage switches, and it's all kind of very rigid and strict. And you know, when you want to create a more complex topologies, you have a exact standards. How that applies in OT world, and you know, they were mentioning some RS-232, RS-485, J1939. There are topologies, there are technologies which using twisted pair, 2 wires. I've been working in one plant, one power generation plant. They used still coaxial cable to run data between the controllers. And then suddenly you're talking, it's already talking about different physical layer. Then there is not like in IT, you do have the Ethernet. We're moving more and more towards the Ethernet. But there are again also disadvantages. There are companies like Siemens created Profinet. There is ArcNet. There is Ethernet IP from Rockwell, from Alan Bradley. These technologies trying to make it more OT friendly. But when you're considering an IT layer, when communications between your computer and to other computer, to server and back, going across maybe multiple switches, firewalls, routers, and they all delaying the system. And the system is designed to send a package of data. And if the package is not received, you're gonna resend it. This is, for example, in CAN bus doesn't exist. Once you send a package and you don't have a reply, the network collapses because the design was done 30, 40, 50 years back. And of course, to move from this into new world, we need a technology or device step up. And we need to still understand the technology which is out there. Advantage of it, why would somebody use RS485 twisted pair cable? Because you can run it for 1 kilometer and get data very cheap way, considering. You can try to put a Wi-Fi on it, but Wi-Fi is not gonna run 1 kilometer and not in a building. And as soon you do have a multiple Wi-Fis around, your data lost on a, for example, from some operation protocol will be so massive when you're gonna have a mess and not the data. You're gonna miss so much of informations on a network. Then this is important to understand and put this technology together to how you can use Wi-Fi, of course, but you have to have on both side protocols which can work with the Wi-Fi, are compatible, and are able to communicate without data loss. Because the data loss actually can decide and make a decision of losing the secure and safety on site. When we're going further of that, I said it a few times, that security is in a design, and the security in design is one of the slogans actually for remote access products what we have. I'm quite new into OT Ethernet side, because before working in IT, but in OT, actually I ran into all the serial protocols and was working with that. New, I'm talking about 10 years. 10 years is enough information to understand when you're not putting correct features in your network, you're making it insecure, you're making it easy to collapse, but also what you're making it not able to scale it up in the future. Because if you, with every machine, you're gonna send a different products portfolio, so with the different network features, it will cause problems for you in the future. Higher cost of maintenance, higher cost of security for the security. It's very hard to say how the world will evolve, but we can see the digitalization is gonna be part of it. If we're gonna start, we should start probably decades ago, but start to design OT layer with that in mind, when we will, because the people which using the data, people which interacting, they gonna connect through it through the IT. If it's mobile device, if it's computer, or it could be some different. These days, augmented reality. Yeah, I had done a few projects on augmented reality. It works in what we call a studio environment or laboratory environment. Is that applicable in proper manufacturing side? Not yet. It will come there, maybe in 10 years. Technology, and this is again, software technology is capable of doing it. There is the hardware part which is lagging. There is the physical part of the technology which is not at the level yet. And of course, you need to all interact, all connected in some way and save way. That's what I see is my living on the end. So on the end, this is gonna be living for probably my 2-3 decades, and I can't fall asleep, and I don't think anybody from manufacturer of machines, manufacturer of products, anybody from OT world should fall asleep, because this change is here already, and you can't ignore it.
Thank you. If do you want, if Ian and David like to make a quick comment on that, we'll move on to Ian's presentation. If you have anything to add. No, that's good. Ian, do you want to quickly talk on the physical side, expanding on anything you have yet to cover?
Well, you know, safety generally, and we've had this conversation before. Safety is such a big bucket. Even when you focus on the subject line, it's really difficult to cover everything that you want to say because there's so much to say.
Yeah.
I think for me, going back to the risk assessment and the end user's requirement, the best way to deal with safety is to physically segregate dangerous parts of the machine from access from people who sometimes aren't as focused as they should be. You know, the first time I saw a dual mushroom press, I thought, what a fantastic idea that is to save people's fingers. That's a pretty good example of you physically can't have your hand under the press if you've got to have them on a mushroom. You know, when I say physical safety, it doesn't necessarily mean that you have to put an 8-foot fence 12 feet away from a machine or a production line, but steps to prevent that particular process from causing a problem. I'm an advocate that I think when you look at the different safety levels and you look at the type of software that exists within many different machines around the world, we should have a standard, one single standard that consolidates and everybody's working to the same, or everyone's dancing to the same beat, if you like. I don't think that will ever happen because the same reason we had VHS and Betamax, and you know the same reason we've got 3 different mobile phone technologies around the world, the same reason that wireless safety has to jump through hoops depending on what part of the world it exists in. It has to be tested. TUV test a lot of our wireless equipment to make sure that it does the right speed of action over the 800 meter distance that we've got for wireless safety. But I mean, fundamentally, if you restrict access by using trap key systems, our trap key system is unique in that it's linear, it's ATEX in some locations, you know. It's effectively on and off switches. If you want PLE, then there's 2 solenoids, for example, comply with the latest machinery directive, and that it has the ability to, you have something in your hand. You know, you are physically not allowed in unless you put the key in, and then you're not allowed to turn the machine on until you've taken the key out. So that is a very basic low down IO. You know, if you know binary, it's on or off. So you know that was the original piece of software. We still sell ever such a lot of that kind of technology in PLE environments in conjunction with our like UH6900 wireless safety, where it's not practical to run a cable a kilometre to get RS485 out the other end because there's interference, or a cable will constantly get cut in half, or you know, they haven't got an electrician to come and open the control panel for you, Pete. So you know, it's a very focused thing where UH6900, our wireless stuff, which I wasn't talking about, but you know, it's been on the subject today, is available for that kind of expansion, and you can't hack into it, our UH6900, because the protocol's bespoke, doesn't run on Ethernet. And what we find is there are manufacturers out there, people try and have a smaller distance on 2.4 gig or 5 gigahertz radio frequencies, and they find that it falls over a lot. And the reason it falls over a lot is because the frequency is too fast. And it's okay if it's a computer, it waits until the next packet arrives. But for safety, you can't do that. I don't have ever such a lot of stuff to cover because, you know, I enjoy our conversations that we all have, and if only we were very local, we could all go down the pub now and have
Sounds
a pint.
like a great idea. David and Peter, do you want to add anything to what Ian has said that we haven't already covered, or are you content?
No, I don't think so. I think the one thing you mentioned earlier on about the standards keeping up, Andy, and is there a disparity between what is actually practically happening in the industrial environment and what the legislation and the standards provide in terms of guidance? The regulations are very general in their approach, and for that reason, we've got to make sure our machines are safe. And that's the legal bit. They're the bits that you've got to comply with, and they're the bits you're going to get prosecuted under. The standards themselves, let's say that they're best practice documents in most cases, and there's this presumption of conformity to using them. I would never suggest anyone doesn't use them. I would always recommend using the standards, and I'm a strong believer in the technical content. But we have seen technology advance quicker than the standards do, and that's why we have these great standard committees that are rewriting these all the time and working on them. But you can imagine it's a relatively slow process. And going back to Ian's comment earlier on about one standard software platform to get everyone to agree, I'm not sure we'd ever get there, and I think Ian acknowledged that a minute ago. So
I don't think that will be even good. I don't think that will be even good. Yeah.
But I think when you look at take cobots, there's been a massive advancement of cobots being used on the factory floor, and we've seen it. And actually, if you go and see how a lot of the applications have been provided into those environments, quite a lot of them I would deem as not necessarily being safe. And simple things like pressure and force measurement on a cobot within a factory environment. And I don't know whether you saw, there was a YouTube clip flying about recently where they got a cobot to pick up a very large knife, kitchen knife, and start swinging it around. People automatically assume that a cobot, because it's a cobot, is safe, and it's couldn't be further from the truth. And we're seeing a lot more guidance, either in technical reporting or as standards move in place to try and cover this. But that was a perfect example of where I think the technology was a little bit ahead of the standards at the time.
Yeah, and I think that is a factor. And I mean, geographical variations in standards, I suppose, is the other area, isn't it? Where the big trading blocks have standards, the US, the EU, Asia, and so on. But are they ever going to come together in a uniform set of standards that are applicable to everyone, which would be a great outcome, I guess?
Yeah, we made up Apple to create use USB-C now, and who knows?
Okay, brilliant. So thank you ever so much for that. I'm going to ask you just to comment on two questions. We mentioned the issue of data and the ownership of data. Now, this does seem to be quite a tricky area, particularly, for example, we've just rejoined Horizon. I mean, will that sort of small steps a little bit down the line make data transfer less of a hurdle between, say, the UK and the EU? What other hurdles are there in terms of ownership of data external to companies and indeed internal to companies? Who should have access to what and so on. So I don't know if anyone has any comments on the hurdles, if that's the right term. It's Peter's term, wasn't it? The hurdles of data, and whether that's a problem. And then secondly, just as we close, where do you see us all in 5 years' time? Obviously here, but
for me, that's 7 years near retirement. 7 years of my retirement. Yeah.
Well, my father retired at 89, so I've got a fair while to go. Yeah.
Yeah, but it's good when you believe in a retirement. I lost that trust and belief in that many years ago. But it's probably down to the generation and the world how I see it, perceiving it now. My dad refusing to retire, and he just said that's not for him. But I do know other people which they just could not wait to go to retirement, and then they get bored, and in 5 years they return back because they said, "Oh, it's not for me." Then it's everyone's got a different approach. From my point of view, if we're not gonna stop educate ourselves, because that's kind of major things of progress, we will be here enjoying again the knowledge what's happening out there and able to communicate it. If we're not gonna what we call fall asleep, that's one of the major things. Not to fall asleep, not to be blinded, stay open with a vision wide. And I'm sure there will be always a place in this world where we're gonna be able to apply our knowledge. And if it's gonna be safety, security, times will show. But somebody once said, "Oh, you got a good programmer mind." For me, 1 year of doing programming gave me absolutely showcase this is not for you. Don't do it. You know, maybe in 5 years we're gonna find out when there is something even more exciting us. On the end, I think we should be satisfied with our world, and the world will spin. We're not gonna stop it.
Very true.
But now,
very true.
But now, Peter, you can ask AI to do the programming for you.
They don't. I will be a bit more skeptical in this, because in my case, in my opinion, when they will produce AI, hopefully I will be still alive. At this moment, it's AI marketing.
No, not necessarily. No, I built 3 websites in about 10 minutes using AI, which was PHP based. I had the server knowledge. It was very, very easy, and people going, "You wrote that quickly?" And no, I didn't write it at all. Asked an AI,
but it's just reusing something what is there. It's not made a new things. That's the thing. All these language models and how they're putting things together. It's interesting thematics, and I think it's small steps in what AI is capable to be. But it's like you will ask 1-year-old to smile on you, and it will smile on you because it sees it's from you. It's inherited the look. If you never will smile on that baby, it will never smile back. But it's taken a while to actually create the situations when it smiles on its own. And it's not that, it's a small step with AIs. I think we are far away from that to have a really independent AIs which actually can create things. And it's a little bit scary to think about it, because if it can create things, what is gonna think about us, and what kind of mirror it will give us? Do we really want that? Because it's like I look in the mirror every morning and think, "Oh, what's going on here?" It's aging. I can accept it or not accept it. Could we accept feedback from AI on ourselves as a humanity? That's a question.
One of my colleagues on my chats just popped up. I could have an AI wife.
Moving on. Well, David, you're far too young to retire. So, where do you see it all going in 5 years?
Thank you very much. That's very kind of you, Andy. Although I'm not sure I believe you. Look, I think we're going to see more advanced technology around the safety sphere, and the general migration and the trends are going to continue. We're seeing a lot more inquiries for field bus systems. I know Ian with DOLD and Euchner both have electronic key exchange systems now, and we've both put our links in the chat for those. But even things like the old, the mechanical clunky systems moving over towards electronic based systems as well. So I see more and more of that. I think the IO link, safety over IO link, is probably going to be also hopefully a big part of the safety portfolio of the leading manufacturers in another 12 months or 18 months, depending when we get the final green tick in the box for the IO link safety.
Brilliant. Okay, well, let's leave it there. Thank you ever so much, guys, for your contributions, which were so fantastic that I've been quieter than I normally am, which can only be a good thing. It reminds me, talking of avant-garde jazz, as I remember as part of an electronics PR journalist group, we were taken to Ronnie Scott's to see a guy called Lee Kernitz on the saxophone, a very avant-garde player. And we were rather rude, actually, and something I wouldn't approve, but we were kind of chatting quietly while he was playing. And he came over afterwards and said, I want you to hum along to the next tune. The benefit of that is you'll keep your mouth shut. So I kept my mouth shut today. I thought the contributions were absolutely terrific. There's a lot to follow up. We will follow it up with everyone on the call and everyone subsequently. And as I say, the webinar is the start of our interaction. So I'm sure that we'll get a lot of follow up from this. So thank you very much for attending. Thank you very much to the panelists for taking part. And we look forward to seeing you at the next Talking Industry in November. All the best and thank you very much.
Thank you all.
Thank you.
Bye.